about how the browser's event loop works and what it is. So just a little context. So all GUIs use an event loop model. Web browsers, iOS, Android, Windows, Mac, Linux. Probably most embedded systems do too, like your Blu-ray player and stuff like that. Like anything that has a graphical user interface probably is using an event loop model to make things appear. This programming model, or other programming models like Angular or other things, might try to hide the event loop from you so that you don't have to know the details. But I find it helpful to understand it anyway, just to have know sort of what's under the hood. Unlike most runtimes, like the JVM and .NET and other runtimes, JavaScript is single-threaded. Asterisk, and the asterisk is, in that statement, I'm ignoring the existence of web workers. If you have a performance issue and you think using web workers is the solution, it probably isn't. And web workers is something that's, the idea is that you have another thread of execution, but you're not guaranteed to actually get any parallelism out of that. Whether or not it's a parallel is an implementation detail of whoever's implementing web workers. So there's no guarantee of actual parallelism with web workers. It just so happens that most browsers implement it such that you get parallelism. But on, let's say, mobile devices, you might not get any parallelism. That's a good question. So what do I mean by single-threaded? Like, what's the scope of that?
Yeah.
And it's single-threaded within a page. So if you have two tabs, that's two threads. If you have an iframe, you have an iframe, that's a different thread.
So each frame's an iframe.
Yeah, although I, again, wouldn't rely on an iframe being a separate thread and using that to gain parallelism. You can think of it as a separate thread in that it's a completely different context, and there's no shared information between these two things. But it's not, I wouldn't rely on it for parallelism because, again, it's an implementation detail, so you shouldn't rely on that. There's no contract that guarantees that that's going to give you parallelism. Yeah. Okay, so this is like a general statement about GUIs that they use in an event loop. But now I'm going to talk about JavaScript specifically. And so this isn't necessarily true for all GUIs. So an event loop has three components. There's a queue of events, and this is just like any other FIFO queue, just first in, first out queue. There's a table of event matchers that, so it's sort of like a key value pair, if you will, so event matchers and event handlers. And then there's a thread, often called the UI thread outside of the JavaScript world, but in JavaScript there's only one thread, so it's sort of weird to call it the UI thread because it's the one thread. Anyone done multi-threaded UI apps in like .NET or JVM, like Swing or anything like that, and had to deal with trying to make sure you do the right thing on the right thread and whatnot? So, so having multiple threads, it's a double-edged sword, like most swords are. And in that you can get parallelism, and there's certain advantages to having multiple threads, but then whenever you're updating the UI, you have to do that on the UI thread. So you have to figure out how to communicate between these different threads. And it's often a point of complexity. So in JavaScript, because you only have one thread, you don't have to worry about that. It's a simpler model to think about. So we'll see how that plays out. So an event is added to the event queue every time there's any interaction with the UI. So every time the mouse moves, even one pixel, every time you scroll, every time you hover, every time you click, every keystroke that you do, there's an event put in the event queue, and then something processes that event. So most events, nothing happens. So it turns out that processing these events is a no-op, but nonetheless, they're put in the queue and they're processed. Also, an event is added to the event queue every time I/O completes. So every time you do a network request or talk to disk, IndexedDB. There's some asterisk in that too. There's some details. So most browsers nowadays, you can get intermediate like progress events when you're just downloading stuff. So you can see when you're at 10%, 20%, 30%. So not just when you complete. And then also there's one disk API called local storage that is synchronous and not asynchronous. So there's no event that's generated when that's completed. It just returns back control back to your JavaScript. So so this is sort of the event handler table. On the left, we have an event handler matcher, and on the right, we have an event handler, which is always a function. So the idea is, for example, right here, such as an AJAX callback. So you're going to get a URL, and when you successfully completed getting that URL, call this function. So the function that's being passed to success is a callback, and that's the event handler. The event is the URL successfully being retrieved. So there's sort of like one-time events, like this particular HTTP request, when this returns, this is a callback for it. There's also sort of small class of events, so like a click handler, when you click on a button, you call this function, but you can click that button more than once, so it's not a one-time event, but it's pretty specific. And you can also have event handlers on like a large class of events, so like whenever the mouse moves a single pixel on the page, call this function. You probably would never want to do that, but you can. It's an option. And then the event loop, I'm sure this is not how it's actually implemented, but this gives you an idea of how it works. So this thread, this is JavaScript's one thread, right? So all of your code, all your JavaScript is running on this thread. And so at the highest level, this is essentially what this thread is doing. It's always running, so while true, it's an infinite loop. There's an event queue, it pops off the event queue and says, not event here, says if there wasn't an event, then just continue. So you just keep on checking that queue to see if there's an event. The question was, would pop return undefined if there was nothing in the queue? And the answer is yeah. So if there's an event, then we go to the event handler table and say, hey, event handler table, find me all the functions that I should call as a result of this event being raised or happening. So this find all handlers for event returns an array of handlers, which might be empty, but it's an array. And then for everything that's in that array, I just invoke the handler and pass it the event. Like, hey, handler, this thing is happening now. You should be able to write your program such that you don't care the order in which your callbacks are called. There's some nuance in there, like if you're doing event bubbling in the DOM, that's a slightly different mechanism for doing callbacks than what we're talking about here. And there is a defined order with event bubbling. There's a very defined contract of how that works. But generally, if you say, attach event handler, click event handler to this button, and then later on you say, attach a different event handler
the whole page
to that button, or the whole page, whatever. You shouldn't assume that it's going to be that those are going to be called back in any particular order. So most JavaScript reacts to an event, and I would even go as far as to say that it should. So you should try to write your JavaScript such that you're not running immediately, but rather you're registering an event handler. So on the top, we've got some jQuery code, and on the bottom we have some Angular code, just for people who are perhaps more familiar with jQuery. So the idea is that here the white code is what's going to run as soon as the file is loaded, but the white code is basically just setting up, attaching event handlers to it. So it's registering event handlers, and then the green code is the actual event handler. So in the first example, when the page is ready, and then we can talk about what ready means, but it's an event. When the ready event fires, run this code. And then on the bottom, there's through some indirection, when a controller is instantiated, which is a result of an event, run this code. So generally, at the sort of the highest level of your JavaScript, you don't want to do any real work there other than just registering callbacks, or registering event handlers. Okay. Event handlers. Oh, this is a weird English. Sorry, I didn't finish editing the title. So event handlers are guaranteed to run to completion before another is executed. So if you think about, you have this queue and the thread is going through the queue. It's one thread. It pulls an event off the queue. It calls all the handlers on it. It's all synchronous, right? So any one handler is guaranteed to complete before the next handler is ran, because it's all just in a loop. Also, the processing of one event is guaranteed to complete before the processing for the next event begins. So, for example, here we have a variable called data that we're going to assign as the result of a callback to this, getting this URL. And then while not data, we just loop, because the idea here is maybe we're trying to wait until the HTTP request is completed before we move on. But this turns out that this is an infinite loop. And the reason why is because this, the var data and the $HTTP and the while, this is all as a result of some event, right? Because all JavaScript code is a result of some event. So whatever that's calling this HTTP get, this event is guaranteed to complete before we actually process the callback for the success. So that data equals response, that's not going to run until this while loop is completed and I return from whatever function I'm in, and then it goes back to the event loop so that it can go and grab the next thing off the event queue. That's a good question. So I'm going to draw on the wall here. So here we have our queue, and it's FICO, and we're going to say that this is the head. So the bottom is the head. And so let's say this is the load event. And then let's say the load event is what's causing this JavaScript to run. So we have, this is our handler table. And so this is, on the left we have our matchers, things that match against the event. And then this is the handler. And so we must have had a handler for the load event, otherwise nothing would be running right now. So let's just call this the example function for lack of a better. So at some point we registered this code to run whenever load happens. Load has happened now, and then you have the thread that is processing this event, found this handler, executing that handler, and now this code is running. So we call HTTP get URL success function response. So that second line is registering a new handler. So we'll call this HTTP success. Whoops. Well, spelling. And then this is the function that's up there. So by calling this code here, HTTP get URL success, we've registered a callback. And we've gone ahead and issued the HTTP request, so that's happening right now. And then now we're waiting for data to be set, so we're in this infinite loop. So at some point, HTTP success comes back, and it's successful, right? So now let's say this event has occurred, so we'll put that in our queue. But the event loop can't process this until it's done processing the load, and it's stuck in this infinite loop, so it'll never get processed. This HTTP request. This HTTP success. Because it's one thread. This thread has to return, so it can go back to the loop that goes and pulls the next thing off the queue. Does that make sense to everyone, or is that confusing? All right, good. Lots of nods. So if you have like the DevTools open and you look at the network requests, while you're in this infinite loop, you can see the network requests actually happen and come back. Because because it's more than just JavaScript in the browser, right? Like the browser itself is written in C++, probably.
Yeah.
So the browser itself is what it's written. And so it has another thread, it's doing the network request, and so it's able to handle the response, and then it adds it to this queue, and you're just waiting for JavaScript to catch up. So if we want to do something after the HTTP response is returned, which is the name of the function, this is something that you can do. You just put it there instead. Okay. Set timeout. So let's say, there's a typo here. The 100 should be the second parameter, I think. So just imagine the function is the first parameter, so the two parameters are just flipped. So set timeout, You guys all familiar with set timeout and what that does? Anyone not know what it does? Okay. Okay, good. So what set timeout does is it's saying in 100 milliseconds, run this function. That's basically what it's doing. So, so what this does is it registers the function as a handler to a specific timeout event. So the idea is in 100 milliseconds, a timeout event will be added to the queue, the event queue, and then this is registering that as a handler to that event. And then after 100 milliseconds elapses, the event is added to the queue. I put an asterisk here because it's not technically 100 milliseconds. I can talk about that. And then the event loop will eventually process the event. So let's just ignore the asterisk for right now. Let's just assume that 100 milliseconds, the event is added to the queue. It could be the nth item in the queue, could be the 10th item in the queue. You're processing whatever you're in the middle of. And so it's really not guaranteed that your function is going to run at 100 milliseconds, right? It has to finish whatever it's processing before it gets to this guy. So the asterisk is, as more and more time goes on, modern operating systems are what's doing timer combining timer triggers. And so, like Mac OS famously did this in their last major release. And iOS does this, where if you have two events that are going to fire, let's say, within a millisecond of each other, it'll actually delay the first one a millisecond so that the CPU can sleep a whole millisecond longer to save battery power. So that's how they squeeze out more battery power out of like the MacBook Airs and the iOS devices and stuff like that. So the 100 milliseconds that you're passing to set timeout is actually a suggestion. So it's going to be no sooner than 100 milliseconds and within some reasonable time after 100 milliseconds. Could be 101 or 110, you're not sure. So if you're trying to do animation through set timeout, like every 100 milliseconds you want a frame, this isn't going to work for you. Your animations are not going to be smooth. So if you want to do animation, your best bet is to use CSS3 animation because that's hardware accelerated. That's not done in JavaScript. It's done mostly on the GPU, which is even faster than the GPU. And if you can't do your animation through CSS, there's a JavaScript API called Request Animation Frame, and that's kind of like set timeout, but specifically for doing animation. It has a different contract to timing. So the Angular $apply process, simplified. So who has had to use $apply here? Oh, come on, more hands. I don't have any chocolate this time, but all right.
Or we think we need it.
Or you think that you need it. Okay, so for the rest of the folks, let's see. Let me just jump ahead to this since most people don't know what I'm talking about. So on the left-hand side, let's say we're going to use set timeout, and in 100 milliseconds here, we're going to set a scope variable foo to hello world. And this will not do what you want. So after 100 milliseconds, this fires, quote unquote 100 milliseconds. Scope will be set to foo, but you won't actually see that in the UI. So you would expect that in this div you would see hello world, but that doesn't happen. Here is where you would use $apply. So if you wrap scope.foo equals hello world inside of a $apply, then it does the right thing. And so people who are new to Angular or have been using Angular for a while get confused about when do I use $apply, when I don't, why do I have to use it. And sometimes it says, oh, you're already in an apply loop, so an exception gets thrown and all this stuff. So I'm going to explain why you need to use $apply. So let's say you have like an ng click on an element and you click on it and some function runs. This is what happens. So first, an event occurs that Angular is handling, like an ng click. Angular calls your code, so you've specified some click handle. After your code returns, Angular checks to see what's changed on scope. So you've changed some variables, like you said, scope.hello world. So Angular looks to see what's changed. Then based on what scope changes have happened, Angular calculates what changes to the DOM need to happen. The DOM is the document object model for the folks that are new to all this. So your HTML is a tree, right? And so the DOM is sort of the in-memory structure that represents that tree. So Angular calculates what changes to the DOM that needs to be made as a result of your scope changes, and then Angular executes those DOM changes. When you use Angular to register a callback, Angular actually registers itself as the callback and then calls you. So when you do ng-click and you click on something, it doesn't immediately call you. It actually registers itself as the click handler, and then that click handler calls the code that you said that you want to run. And the reason why that's important is because after your code runs, Angular needs to have an opportunity to go change the DOM as a result of whatever changes you've made. So when you, I just did the second and third point. So when you don't register, when you just do a direct
on-click.
when you're just using the not Angular to attach click handlers, then Angular doesn't get a chance to run. You'll make the changes to the scope variable, but then the DOM's not going to change because Angular's not in the call stack. So there's set timeout and set interval available in the JavaScript environment. These are global functions. And so Angular provides, if you just, wherever it is that you would say that you're accepting $scope, if you add another parameter there called $timeout or $interval, then this is sort of the Angular version of timeout. And what this affords you is that if you use the Angular version, then you don't have to use $apply. You can just say scope.foo equals hello world, and that translates to the second function here, where it's just doing set timeout with the $apply for you. jQuery learned how not to use it. So jQuery provides a way to manipulate the DOM, and Angular also provides that, but Angular's abstraction is one such that your code never should know about the DOM itself. So as you're developing Angular applications, you have objects and arrays and whatnot, and you have events and callbacks to events, but you don't know about divs. You don't know about table tags or the body tags, and you don't know about CSS classes and stuff like that. So this is all abstracted away from you. And this is for good reason. So one of the primary values of Angular is that it's testable and that you can write fast-running tests without the DOM actually existing as a test run. So this is part of the reason why you should use $timeout, because then you can pretend that 100 milliseconds is fast. So when you're writing a test, you can insert a fake $timeout. Instead of waiting 100 milliseconds or 5 minutes or whatever it is, you can just run it right away and not have your test take forever. Okay, so on the left, this is sort of like the jQuery way of doing stuff, where you might have an ID for a button, and then you attach a click handler, but that doesn't actually update the DOM, right? So now you have to wrap that code inside of a $apply, which is what we see at the bottom left. And then people might say, oh my God, Angular is such a pain in the ass. I have to add this extra code whenever I'm using jQuery. Angular sucks. I hate this. And then I'd say, well, just learn how to not use jQuery. And so pretty much everything you can do in jQuery, you can do without jQuery, just using Angular. And so on the right-hand side, this is sort of the equivalent code just using Angular. Sorry, Angular by default uses either JQLite or jQuery in order to do its work. So even though you're pulling jQuery in, you still shouldn't use it. So the question was, the code on the left, would it functionally work? And the answer is yes, it would. But I think what happens is you sort of start living in these two different worlds, where you're thinking in the jQuery world as well as the Angular world. And also, stuff that you do in jQuery is hard to test. So on the right-hand side, if you want to say, write a test, when the click foo function is invoked, I expect that the foo property on the scope object is set to the value hello world. So on the left-hand side, you have to have a DOM, which is a complicated thing to have in a test. So now this test has to run in a browser, which means it's going to run slower. Whereas on the right, it could run in the browser, or you can run it in Node.js, or you can run it wherever. But now you have to have a browser present, and that slows down your test quite a bit. And also, like, now you have this problem. Okay, so how do you reset the DOM between tests? If you're going to use the jQuery, then you need to actually have a DOM element. That's the idea. Yeah, so it adds a lot of complication to your test. Makes it much harder to write the test correctly, to make sure there isn't interaction between tests, and the test runs slower. So timeout 0 is sort of like a thing that's used to achieve certain tricks, I guess you could say, certain optimizations. So, so when I say timeout 0, I'm either talking about set timeout or using the Angular timeout, either one. The idea, though, is that you're going to set up some callback where, for our timeout where the timeout number of milliseconds is 0. So, what this does, essentially, well, let me talk about when 0, instead of 0, it's 100. So, when you call set timeout, and you have some function, and you have 100 milliseconds, it registers a handler for this particular timeout, and this is some function. But it doesn't put the event in the queue. The event only goes in the queue after the 100 milliseconds. So if you do timeout 0, what happens is that it registers the handler, and then it so when you're done handling your load function, and then you're done handling this, this function is kind of run very, very soon. In most cases, abstractly, you can just think of it as whenever the current callback goes back to the event loop, that yours is going to run. It's probably not true, but it's an easy way to think about things. So why would you want to do this? One is getting to the render faster. So the sooner that you can return back to the event loop, the sooner the browser is going to render whatever it is that you're doing. So for the most part, most of the time, in order for the browser to render something, you have to return back to the event loop. So if you have an event handler that's taking a really long time doing something, like you're calculating pi or doing whatever, the UI is frozen during that time. So you don't want the UI to freeze. You want people to be able to scroll. You want people to highlight text and whatever. You want people to be able to type into text boxes. And if whatever you're doing, you want, like you're running some JavaScript code, you want the result of that JavaScript code to appear in the UI as quickly as possible, then you might be able to identify some things that don't need to run before the UI renders. So an example of this is every time you move the map, we want to store what the center of the map was. So that way when you come back into that application, we show you your map position that you were last at. But what we do is actually do that instead of a set timeout 0, because remembering it is not really as important as showing you the UI as quickly as possible. So you drag, and some stuff shows up that's new to represent the new area that you're looking at, and we want to show you that soon. And then after that's done, we'll go ahead and save on disk what the current map center is. Yeah, it's essentially you're yielding back to the browser so that it can do other stuff than your stuff. Yeah. So if you're doing a really long, like a computationally intensive operation and it's freezing up the UI, but you are truly like, let's say adding a blur to an image or something like that in JavaScript, which I don't see why you would, but whatever, let's just say you are. What you might want to do is break that up into chunks. And so just do that in a series of set timeout 0. So you do the first, I don't know, megabyte of image, and you do the second megabyte of image, and then just in between each megabyte worth of processing, you yield back to the event loop so that the UI doesn't look like it's frozen. Some people in that situation might think, oh, I'll use web workers, because that's kind of like having another thread, and you'll do the image processing on the other thread. But that's, that has its own complexity that it introduces, as opposed to the solution I just mentioned. And I would say that they're roughly the same order of complexity. And you're not actually guaranteed that web workers are parallel. The other reason we might use set timeout 0 is, even though I say learn not to use jQuery, sometimes there's like really useful jQuery plugins, right? Like, so you end up using jQuery anyway because there's like this data table thing or like a popover library or something that's just like, it's going to save you a lot of time if you just use the jQuery plugin. And so sure, you want to use the jQuery plugin. But sometimes what you'll do is you'll set like a scope variable that you expect is going to change the UI, and then you'll tell jQuery, okay, go do something with that UI I just added, right? Like register callback on hover, for example. But that UI doesn't actually exist yet because you've changed the scope variable, but you haven't returned back to Angular for it to actually change the DOM. So by doing set timeout 0, you're saying, okay, I'm going to yield back to Angular so I can change the DOM, and the DOM gets rendered. And as soon as that's done, then do this jQuery call. And now when jQuery runs, that DOM will exist. That's it. Ta-da. I think what you're describing is a slightly different use case than this, because what set timeout 0 is for, you've just done something that's going to change the DOM, but you want to wait till the DOM is actually updated before you do the next thing. Whereas the way I heard what you were describing is that something else might change the DOM, maybe some plugin or third-party tool or whatever, and you want to react whenever the DOM changes, whether it's you or something else that's changed it. The underscore library has a function that just aliases this that it calls defer. Okay. But all it does is set timeout 0, but it gives it a different name so that hopefully it communicates a little bit better about what the intent is.